Hello. In this video, we're going to talk about graphing quadratics in transformational form, which is x minus h squared is equal to 4p times y minus k. Think about what you already recognize. We should recognize that this x term is squared, and we've seen h and k before, but we haven't seen this 4p. Well, this 4p, this helps us find the distance to the focus and to the directrix. And these are new things for you. You see, a parabola is defined by all these points, right? Any point is the same distance to the focus as it is down to the directrix. That's nice because that means this distance right here is the same distance as right here. And you'll get way more into that in pre-cal. But the vertex is still just at hk, and the axis of symmetry is still at x equals h, going right through the vertex. If the p is greater than 0, this number, well then the graph is going to open up. And if it's less than 0, then it will open down. So how does the 4p help us find where this focus and directrix should be? Well, if the vertex is at the point hk, then the focus will be at the point h k plus p, which just means you just go up p from the vertex. And since this distance is the same as this distance, then we would subtract p from the vertex, and this is a line, so the directrix is at y equals k minus p. And of course, if the graph was opening the other way, well then the focus would be down here and the directrix would be above. All right, so let's try to graph an example. We're going to graph x minus 3 squared equals 8 times y plus 1. The first thing I'm going to plot is the vertex, which is at hk. Now, notice that this is x minus h, but it's also y minus k. So I have to use the opposite of each of these. So my vertex is at 3, negative 1. And the axis of symmetry is always going to run right through that vertex at x equals 3. Because this 8 is positive, I know that the graph is going to open up. But right now I don't know p. I know that 4p is equal to 8. So setting 4p equal to 8, I can see that p is equal to 2. So because p is positive, I'm going to go from my vertex and count up 2 spots to plot the focus. So the focus is at 3, 1. The directrix, I'm going to go back to the vertex and count to the opposite direction, and then I'm going to draw a horizontal line right there at y equals negative 3. All right, and at this point, we just need some more points. The only problem is I can't put this into the calculator. So let me show you something else that's special about this form. For a parabola, whenever you have this vertex in the focus, this distance from this point to this point that passes right through the focus, this distance is 4p. So for the parabola that we're looking at, the distance from this through this focus is going to be 4p to connect to each side of the parabola. Well, earlier we wrote down that 4p was equal to 8. So I'm going to go out 4 in each direction to 7 and negative 1 to give me this distance of 8 in between. And those are going to be my connecting points. And that's how we graph given this form. Now I want to try to write the equation given the vertex is at 0, 2 and the focus is at 0, 4. So I start by just looking at this form and I'm going to fill in what I know. The vertex is, the x is 0, so x minus 0 squared is just x squared equals 4p y minus k. So 2 is my k, so I'm going to have y minus 2. The only thing I really need to fill in here is, what is 4p? Well, p is the distance from the vertex to the focus. So you can, if you just draw a quick sketch, you can see that the focus is 2 away from the vertex. So we're going to replace p with 2. This leaves us with x squared equals 8 times y minus 2. All right, finally, let's write the equation given a focus at 4 negative 121 over 12 and the directrix at y equals negative 119 over 12. This looks crazy, but it's not as bad as you think. Now, whether or not you can see that this opens up or down from the beginning isn't too big of a deal, but we should know that it opens down just because the focus at negative 121 is lower than that directrix at negative 119 over 12. But what's important to remember is that the vertex is right in between, okay? And that the focus and the vertex have the same x-coordinate. So if I'm going to find this vertex, I at least know that its x-coordinate is 4. Now to find the y-coordinate is going to be right in between the directrix and the focus. So if this is at negative 119 over 12, this is negative 121 over 12, this must be negative 120 over 12, which reduces to negative 10. So now I can at least fill in the x and y of the vertex. This is x minus 4 squared equals 4p y plus 10. Now I need to figure out p. Well, how far away is negative 120 over 12 from negative 121 over 12? The p, I had to go down 1/12. See, if I'm at negative 120 over 12 and I go down 1/12, I'd be at negative 121 over 12. So I'm going to replace p with negative 1/12 and solve. That'd be x minus 4 squared equals negative 1/3 y plus 10. And there I have it in transformational form. Now if I want to write this in vertex form, I got to solve this thing for y. To do that, I'm going to start by multiplying both sides by negative 3. That's going to cancel out this negative 1/3 on this side and leave me with negative 3 times x minus 4 squared equals y plus 10. Finally, I'll just subtract 10, and now I've got this in vertex form. And we can see that the vertex is still here at 4, negative 10. And if I wanted to, I could continue writing this in standard form, just like we've seen for the past couple of days. All right, I know that this is a lot, but I think you can do it. All right, bye.